Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the compression process in a compressor. Compressors, as well as pumps and fans, are devices used to increase the pressure of a fluid. Work is supplied to these devices from an external source through a rotating shaft. Therefore, compressors involve work input. Even though these three devices function similarly, they do differ in the tasks they perform. A fan increases the pressure of a gas slightly and is mainly used to mobilize a gas. A compressor is capable of compressing the gas to very high pressures. Pumps work very much like compressors, except that they handle liquids instead of gases. According to the structure and working principle, compressors can be divided into piston type and impeller type. Each includes one-stage and multi-stage compression. Thermodynamically, all the compressors are the same, consuming work, compressing the gas from lower pressure to higher pressure. Let's firstly talk about the compression process in a one-stage piston compressor. When the piston moves frictionlessly from the top of the cylinder to the right, the inlet valve A opens. The gas enters the cylinder at a lower pressure P1 and pushes the piston to do work outward. The amount of work during the intake process A to 1 is shown by the area in the PV diagram. The piston then moves to the left, at which both A and B valves close. The gas is compressed in the cylinder, and the pressure increases until it reaches discharge pressure P2. In the compression process, the work consumed is shown by the area. The piston continues to move to the left. The exit valve B is open. The gas is discharged from the cylinder under the higher pressure P2. Work must be consumed. The work consumed during the exhaust process 2 to B is shown by the area. Path A to 1 is the intake process. There is push work. Path 1 to 2 is the compression process. The work consumed in this process is. Path 2 to B is the exhaust process. The push work is. The lead work consumed by the compression process in a compressor then is. The work consumed by a compressor is the volume changed work, and on the PV diagram, it is the area enclosed by the path line and the P coordinate. Secondly, let's talk about the power consumptions by a one-stage piston compressor. The compression process of piston compressor can be isothermal, polytropic, or adiabatic. The power consumption, of course, depends on the compression process. When kinetic and potential energies are negligible, the work consumed is 1. In an isentropic compression process, the work consumed is 2. In a polytropic compression process, the work consumed is 3. In an isothermal compression process, the work consumed is. The reversible adiabatic compression requires the maximum work, and the isothermal compression requires the minimum. Why? These three processes are plotted on a PV diagram in Figure 9.11 for the same inlet state and exit pressure. On a PV diagram, the area to the left of the process curve is the integral of V dP. Thus, it's a measure of the steady flow compression work. It's interesting to observe from this diagram that of the three internally reversible cases considered, the work input requirement for the polytropic case is between these two and decreases as the polytropic exponent N is decreased. By increasing the heat rejection during the compression process, if sufficient heat is removed, the value of N approaches unity and the process becomes isothermal. One common way of cooling the gas during compression is to use cooling jackets around the casing of the compressors. Okay, that's all for this task. Thank you very much, and see you next time.